Okay, I'm going to try something different today. I am going to just work some problems out on paper, kind of like I did for you in class, and we'll kind of see how this works. So this way, maybe I can be my own videographer again, and anyway, we'll just see how this works. Okay, we're going to be solving equations. And we've already solved equations before that had a radical in them. And if you will recall, we wrote down a little recipe where we want to isolate the radical. So that needs to be our very first step. We want to isolate the radical. So what I'm going to do, I want the radical positive. I'm just going to add the square root of x minus 1 to both sides. So I have x minus 3 is equal to the square root of x minus 1. Okay, so now that we've done that, we want to square both sides because we want to undo the radical. So we're going to square both sides because a square undoes a square root. Again, we have a binomial here that is squared. If you can't do it in your head, write it out twice. Look how long that took. That took no time at all. Okay, but this is what I want to tell you guys. Remember, we started out with an x here. When we FOIL this out, we're going to get an x squared. We might introduce a root or an answer that will not work. So anytime you take an x and you x square it to solve, make sure you check your work back into the original equation. Okay, so this is going to be x squared, and then negative 3x, and negative 3x is negative 6x, and negative 3 times the negative 3 is a plus 9. On this side, when we square the square root, we're going to be left with x minus 1. Okay, anytime we have an x squared, we can complete the square, we can factor, we can use the quadratic formula. Let's just move all this stuff over and see which one seems to be the easiest thing to do. So we're going to subtract 1 from both sides. I'm going to add 1 to both sides. And I have x squared minus 7x plus 10 is equal to 0. And if you'll look at that factors. So this is like when we thought factoring was hard, now all of a sudden factoring might really be like the easiest thing to do. So two numbers, when I multiply them together, give me a 10. When I combine them, I get a negative 7. Like a negative 2 and a negative 5, their product is a positive 10, their sum is negative 7. So x minus 2 and x minus 5. Okay, so now I'm going to set both of those equal to 0. Let me move this up a little bit. And y'all aren't here to tell me that you can't see the paper. X minus 2 is equal to 0. X minus 5 is equal to 0. I'm going to add 2 to both sides. So x is equal to 2. Over here, I'm going to add 5 to both sides, and x is equal to 5. So now what I'm going to do is I'm going to plug both of these into the original equation. Okay, so let's start off with the 2. So I'm going to do, let me do it down here. So I've got 2 minus the square root of 2 minus 1 minus 3 is equal to 0. So this is 2 minus 1 is 1. The square root of 1 is 1. Minus 3, so 2 minus 1 is 1 minus 3 is negative 2. And if you'll look, that doesn't work, okay? So x is equal to 2 is not an answer. Let's check 5. Let me see. Let me just move this up a little bit. So I have 5 minus the square root of 5 minus 1 minus 3, and we want to see if that's equal to 0. So 5 minus 1 is 4, the square root of 4 is 2, and then minus 3. So 5 minus 2 is 3, 3 minus 3 is 0, and it works. Okay, this one checks. So we only have one solution, and it's x is equal to 5. So this is just an extra root. It's called an extraneous root. Frequently, you're going to get something that doesn't work if you have taken an x, and in the process of solving, you ended up with an x squared. So be warned, check your work, check your work, check your work. plug it back in if you've made an extra root and check your work. Okay, the next problem, and I think we're going to do several problems like this where we have fractions. Okay, so it's 2x over x minus 1 minus x plus 2 all over x, and that's equal to 5 times, or over, sorry, x times x minus 1. So when we've worked problems like this before, the very first thing that we did is we talked about our restrictions. Okay, so remember we wrote our restrictions on the little line, our little answer bar line. Okay, so to get our restrictions, we're going to set x minus 1 equal to 0, add 1 to both sides, and x is equal to 1. So on your little line where you write your answer, you have to make a note to yourself that x cannot equal 1. Okay, it cannot equal 1. Also, if we set x equal to 0. So what I did was I put this equal to 0, this denominator equal to 0, because remember if you divide by 0, it blows up and we don't want it to blow up. And I'm going to set this equal to 0. So I know my restrictions are x cannot equal 1 and x cannot equal 0. Okay, so make sure that that is well noted so you don't put those down as one of your answers. Okay, so we want to go through and multiply by a common denominator. So when we do that, remember I write the denominator in front or beside every single term. So our common denominator is going to be x times x minus 1. So I'm going to multiply this by x times x minus 1, this x times x minus 1, and this x times x minus 1. Okay, so now x minus 1 over x minus 1 is 1. So we have 2x squared. 2x squared minus x over x goes away. And we have in parentheses x plus 2 times x minus 1. And that's equal to x over x is 1, x minus 1 over x minus 1 is 1. That's equal to 5. Okay, so we've got lots of work ahead of us, but we can do this. So let's go through. I'm going to take 2x squared minus, and I'm going to FOIL all this out, and I'm still going to put it in parentheses because I have a negative in front. So, and we're going to have to distribute that negative. So x times x is x squared. Then I have a negative x plus a 2x, so that's like 2 minus 1, which is a positive x. And then 2 times negative 1 is negative 2, and that's equal to 5. Okay, so what I'm going to do now is I'm going to distribute the negative. So I have 2x squared minus x squared minus x, and then a plus 2. Okay, do you see what I did? A negative times this was a negative, negative times that is a negative, and a negative times a negative 2 is a plus 2, and that's equal to 5. Okay, before we start doing any of our algebraic transformations, let's combine like terms. So 2x squared minus 1x squared is x squared. So I have x squared minus x plus 2 is equal to 5. So I'm going to subtract 5 from both sides, and I have x squared minus x, what is that, minus 3 is equal to 0. Okay, the only factors of 3 are 1 and 3, and there's no way to combine a 1 and a 3 to get a negative 1 right here. So I'm going to use the quadratic formula. So it's going to be the opposite of b. So this is a negative 1. The opposite of a negative 1 is a positive 1. Plus or minus the square root of b squared. Negative 1 squared is 1. Minus 4 times a. A is 1. C is negative 3. All over 2a, and a is still 1. So this is 1 plus or minus the square root of. I have 2 negatives make a positive, so 4 times 3 is 12, plus 1 is 13. So 13 over 2. So this is my answer. This doesn't come into conflict with any of those restrictions. I didn't get a 0. I didn't get a 1. These are my two answers. But let me just tell you this. You have to write this on your test as 1 minus the square root of 13 over 2. And I don't know how you do that over 2 when you type it in the computer. I have no idea. And then it's going to be 1 plus the square root of 13 over 2. And it'll give you a bar to type your answer in, and it'll have braces on either side of the bar. You don't have to put in the braces, but you do have to write this as two different fractions. Okay, next problem. This is just kind of a problem I want you to see just in case you come across something like this in Math Lab. First of all, we're only working in real numbers. All we're doing is working in real numbers. So this is something that can be factored. So to get x to the 4th power, it's going to be x squared and x squared. I want two numbers. When I multiply them together, I get negative 36. When I combine them, I get 5. So let's look at 9. Was this 9 and 4? So if the 9 is positive and the 4 is negative, 9 minus 4 gives us a positive 5. 9 times negative 4 gives us negative 36. So this is going to be plus 9 and minus 4. Okay, we know this is not factorable. Okay, this is not factorable. If we had spent time going over real numbers, we would get going over imaginary numbers, sorry. Here you're gonna get two answers that are not real. Since we're not worried about not real, we don't even have to worry about that, but you can't factor that. This you can factor. This is the difference of two perfect squares. X squared is x and x. A negative 4 is a plus 2 and a minus 2. So now I'm gonna set both of those factors equal to 0. And I'm going to subtract 2 from both sides, and I get x is equal to negative 2. I'm going to add 2 to both sides, and I get x is equal to 2. So 2, or I guess we should put the negative first. Negative 2 and 2 are your two real number solutions. That's your real number solutions. That's all you have to worry about. The other two solutions are not real. And you guys are smart enough to know that if you have x to the 4th power, you're going to get 4 answers. So here are 2 of them. The other 2 are not real. Okay, let's work 2 more problems. And then that will be all I have for this section. Okay, so again, let's talk about our restrictions. We want to set x equal to 0. Okay, that's our first restriction. Our second restriction is we're going to set x minus 2 equal to 0. We don't want this to blow up. We're going to add 2 to both sides, and x is equal to 2. Okay? Oh, can you see that? X is equal to 2. Let me try to move my camera over just a little bit. There we go. This is kind of hard. Okie doke. So we're going to multiply by a common denominator. Our common denominator is x times x minus 2. So I'm going to write this in front of every single term, or beside every single term. I guess it's not really in front, it's just beside. Okay, so let's go through. X over x is 1, so we're left with 3 times the quantity, x minus 2, plus x minus 2 over x minus 2 is 1, so we're left with 3x, and that's equal to x times x minus 2. Okay, so let's go through and we're going to multiply this out, get rid of the parentheses. We want to get rid of all of our grouping symbols. So we have 3x minus 6 plus 3x is equal to x squared minus 2x. Okay, so I'm going to combine like terms. So I have 3x and 3x is 6x minus 6 is equal to x squared minus 2x. I want to keep my x squared positive, so I'm going to subtract 6x from both sides, and I'm going to add 6 to both sides. So I have x squared minus 8x plus 6 is equal to 0. Okay, when you go through and list your factors of 6, 1 and 6, doesn't give you an 8. 2 and 3 doesn't give you an 8. So let's use the Pythagorean, or let's use the quadratic formula. So the opposite of b, which is 8, plus or minus the square root of b squared. I should grab my calculator. 64 minus 4 times a times c. Oh, we can do this one. All over 2a, and a is 1. So this is, let me move this up. This is 8 plus or minus the square root of 64 minus 24 is 40, all over 2. Okay, 40, just for the sake of time, isn't 40 4 times 10, because 4 is a perfect square is the reason why I did that. So this is going to be 8 over 2 plus or minus the square root of 4 is 2 times the square root of 10 over 2. So 8 over 2 is 4 plus or minus 2 over 2 is 1. So that's the square root of 10. Okay, those are your two answers. In Math Lab or on your test, you're going to have to write this as 4 minus the square root of 10 and 4 plus the square root of 10. And the braces will already be supplied for you. Okay, this is very, 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 very similar to a test question you're going to have. Okay, just like this one is very, 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 very similar to a test question that you're going to have. Okay, so we have, let's talk about our restrictions. Can y'all see this? It's 4 over x plus 4 over x minus 4 is equal to 1. So our restrictions, we're going to set x equal to 0. That's a restriction. We're going to set x minus 4 equal to 0. Solve, add 4 to both sides, and x is equal to 4. That's a restriction. Okay, so if we get either one of those for answers, it's not going to work. Our common denominator is x times x minus 4, x times x minus 4, x times x minus 4. Okay, so the x's, x over x is 1. So we have 4 times x minus 4 plus x minus 4 over x minus 4 is 1 plus 4x is equal to x times x minus 4. Let's get rid of the parentheses. 4x minus 16 plus 4x is equal to x squared minus 4x. Combine like terms, 4x and 4x is 8x minus 16 is equal to x squared minus 4x. So I'm going to subtract 8x from both sides. I'm going to add 16 to both sides. And I have x squared minus 12x plus 16, I'm going to put my 0 on the right side, is equal to 0. Okay, again, factors of 18, 2 and 8, 4 and 4, 1 and 16, and that will give us a 12. Let's plug it into the quadratic formula. So the opposite of b is 12, plus or minus the square root of b squared, which is 144, minus 4 times a times c, which is 16. Okay, so this is, what is this? This is 144. Okay, you can't see what I'm doing. I'm trying to show scratch work, but you can't even see what I'm doing. Okay, all over 2a. Let me do this. All over 2a. Sorry, kind of got distracted, worried because I forgot to bring my calculator over. So we have 144 minus 4 times 16 is 64. So that's 80. Okay, we can do this. So this is 12 plus or minus the square root of 80 divided by 2. Okay, so this is going to be 12 plus or minus. Okay, 4 is a perfect square. 4 goes into 80 20 times. 20 has a perfect square of 4, and so we're left with 5, and all of this is over 2. Okay, so 4 times 5 is 20, times 4 is 80. So I just broke 80 down. You could do it any way that you want to. So I have 12 plus or minus, I have 2 4s, so bring out a 4 times the square root of 5, all over 2. So each of these numbers, 12, 4, and 2, are divisible by 2. So I'm saying, do I have the right thing? So 12 over 2, sorry, let me move this up. 12 over 2 is 6, plus or minus 4 over 2 is 2, times the square root of 5. Okay, again, on your test, please write this as 6 minus 2 times the square root of 5, and 6 plus 2 times the square root of 5. The braces will be supplied for you. Okay, the problems we just worked, but not necessarily the one that had the imaginary roots in it. You might have that in math lab, but you won't have it on your test. The problems that we just worked are very similar to a couple of problems that you're going to have on your test. Please rewrite these problems, do them again, and again, and again until you have got this mastered. Then when you get ready to study for the test, do them one more time. This is the problems that I'm giving you guys are very, very, very good preparation for your test. So you guys, the class average on the last test was like an 85. You guys are rocking this. I want you to keep rocking it. So good luck, and I'll be with you in just a little bit with section 8.4. Bye, guys.